This question is all about knowing your statistics vocabulary. So you have no real choice here. You have to memorize some stuff. It honestly ends up being easier than it might look at first because we don't actually need to memorize things completely. I'll show you what I mean. But let's start with the easier term, which is range. Okay, and that's down here, the range respectively, so that's the R part. So range, that has a very easy formula. That's something we should be able to calculate on most statistics questions if we are asked for it. The range is the maximum value minus the minimum value. Easy to calculate. So for the first one here, that's going to be 88 minus 56. And yes, I am going by the extremes of the graph, but it's not just because they're on the ends, it's because they also have points at those places. So it's important that you're not just measuring the scale, you're measuring where the final maximum and minimum value are. So okay, 88 minus 56 is 32. So R1 is 32. And we can do the same thing for the second graph, and that's going to be 112 minus 80, and that's also 32. So, okay, great. They're equal. So which one has them equal? Either A or D. So just knowing that one definition gets you down to a 50-50 chance on a very difficult question, right? We're near the end of the section, so 50-50 shot is pretty good. The other part then is asking for the standard deviation, which is a term that is a little bit less common. We don't tend to learn that when we're younger. We might learn range, but we don't tend to focus on standard deviation until we get into more high school level math. And even then, it can get a little overwhelming. There are ways of calculating it, but on the SAT, you will never need to calculate it. You just need to understand it as a concept. So what is standard deviation? It's a measurement of the spread of the data. So is there a lot of spread or is there very little spread? So right now, to be clear, the choice is obvious for us. These data sets are different, right? One has a lot of numbers around 72 and they all kind of look like a big peak. The other one doesn't. It looks a little different, looks a little more flat. There's a difference there. I don't need to understand what the difference is like and how that affects the standard deviation. I just know that they're different because look at my choices, A and D. A says that they're going to be equal and D says they're not going to be equal. So D is my bet. These things look different, so it's probably the case that whatever standard deviation is, it's also different. That's a perfectly valid reasoning here, and especially if you're running short of time and don't know what standard deviation is, just pick this and move on. There you go. But it's also true, and I'm going to show you, we actually know whether S1 or S2 is bigger, right? So let's talk about spread. The points in the top one are not very spread out, right? So there's a little bit of an edge there, but for the most part, these points kind of fall into the middle, right? There's a clear peak, a clear mountain. All of the points are smushed together. They're not spread out. They're bunching together around this middle number 72. So S1 has low deviation, low spread. They're not spread out. They're bunched together. Whereas the second one does have high deviation. Look at this. There's no real clear middle. These points are more like a rolling set of hills, not a big mountain, right? They're spread out. It's more flat. So S2 is going to be higher deviation because the points deviate more from whatever the middle may be. In fact, I don't even know what the middle is. So it's usually easy to see whether or not a set has a high deviation or a low deviation, especially because we're only really going to be comparing one set to another. We're not going to be asked kind of in isolation what the deviation is. So in this case, just to make it really clear, S1 is less than S2. So that would mean that B would have been right if they had the right part about the ranges. So there we go. That's an important concept to know. You kind of got lucky here that we didn't really need to know whether the first set or the second set had a greater or lower deviation. We didn't need to separate those things out, but we could have, is my point. So for this question, we got lucky. We just needed to know that they're not the same. But for another question, we might need to know that, and we can know that. Just look at the spread of the data. Does it bunch up or does it flatten out? And now you know. Important definitions. Make sure you memorize those.